I'm not going to do a huge amount of talking again at the top, even though we've got some examples. I'm going to work through those. But the properties are the exact same ones that we talked about yesterday. The only difference now is we have fractions to deal with. So, is that going to cause us trouble? Not really. Here's the one thing I will mention right at the beginning, though. If you're going to use the properties of exponents, just like we did yesterday, whether it's a variable, whether it's a number as your base, your bases have to be the same for you to be able to do the operation. In other words, in this first example, these are both 3's. If one was a 3 and one was a 2, I couldn't add the exponents. Or if one was an x and one was a y, I couldn't add the exponents like I tried to yesterday with m and n before y'all fixed me on that. So, but if they are, again, if you're adding with fractions, you have to have a common denominator. We're lucky this time we do. And I'm going a little over the top with my steps because, again, it's examples, it's notes. I want you to see where everything's coming from. So I add the 1/2 and the 3/2, gives me 4/2. That reduces down to 2. And then 3 squared is 9. I can take it all the way through. Power to power, we're multiplying the exponents. Now again, could I do that on the calculator? I sure could. 6 over 2 is 3. So I'm never going to tell you again on these that, especially if it's a number, you can't do something on the calculator, but you want to understand the rule for just in case. So even on this one, it's going to look strange, but let's take a peek here. Now see, that was just wild. I didn't need to do that. 4, 3 over 2. Got to get that back in. Then I can take it to the second power. I get there. So again, your call. Here I can distribute or I can multiply them together. Doesn't matter. Now, this is the situation I was talking about before. I can't add the exponents. The 9 and the 4 aren't the same base. But if I can simplify them, what's something to the 1/2 power mean again? Square root. So the square root of 9 times the square root of 4, and I can still get there. So it really just becomes, do we really understand the basics that we talked about yesterday? Negative exponents have to get flipped to turn them positive, and then again, square root of 25 is 5. And we just keep rolling these through. Division, subtract the exponents. 5/2 minus 1/2 is 4/2, or 6 squared. And you just start getting yourself used to not only the exponent rules, but hopefully you're starting to get used to at this point. Maybe if you've been using the chart, or even if you've been typing it in your calculator, recognizing, hey, with this 3, that's my index, my root, so that's a cube. Hey, that's a perfect cube. And so is that. It's going to make you faster, and it's also going to make you less likely to make errors. So that's where all the practice starts to come in. So again, with these, I know it says, okay, directions are important. Use the properties of rational exponents to simplify. No calculator, leave the answer with an exponent. So I'm not looking, I'm about to break my own rule, but I'm going to show you why I'm breaking my own rule here. Okay, I'm not looking for 3.35. I don't want that. Here, I need to add my exponents because I'm multiplying. I need a common denominator. This is not 2 over 6, okay? If doing the common denominator in your head, which would be 4 in this case, so 2 times what gets me to 4? 2. We do the same thing to the numerator. If that is causing you to sit and stare or wait on a problem, I can't put the whole problem in the calculator, but if I needed to at some point, I absolutely, oops, I don't want to hit enter though, can put the exponents and adding into my calculator and do math enter enter and get 3/4. So as long as you know the rule, you have tools to get you where you need to go. These, I can't multiply them together. You're like, well, wait a minute. Now, Hardy, you set up here. Well, there's 9 times 4. You said if we wanted to yesterday, you could multiply those together and take the root. Now you're telling us we can't. Why? Because now the roots are different. Either your exponents would have to be the same for you to be able to do the operation, or your exponent. So the exponent or the base. Here, neither of them is the same. Those aren't the same, neither are those. So our only option is to go ahead and multiply our exponents. Half of 2 is 1. 1/3 times 2 is 2/3. I can't do any more. I can't multiply these together. They're not the same exponent. I can't add the exponents. They're not the same base. So that's it. That doesn't happen a lot, but it happens some. And so let's see here. Where else can I play? Am I going to get to play with negatives anywhere else? No. So we'll play with them here. Okay. Here, 4 times -1/4 is -1. 4 times -1/4 is -1. Don't leave it. Well, I can't multiply them. I can't add them, but you can with this. Did I just do something? No, I didn't do something crazy. I thought I did something crazy. I can, again, they're negative exponents. I can flip them. And I've mentioned this before. If sometimes you forget about that, just make your whole numbers fractions by putting them over 1 to remind you. Then I can get there. I can go a little further and work those through. Or if you get to some value that you look at and you're like, okay, so if I do that here, that 2 is just multiplying times your numerators here. So 1/3 times 2 would be 2/3. And 1/4 times 2 would be 2/4, or 1/2. And you're like, can we do anything with this? 27 to the 2/3 simplifies, okay. But the square root of 6 doesn't. So, I mean, you could leave it as 6 to the 1/2, or you could just change it to the square root of 6. Either one. Again, we're always looking, can I go a little further? Just a little bit. Same base. Okay, we have hope here. So this is 7, 1 minus 1/3. 1 minus 1/3 is 2/3. As far as I can go. So most of the time there's going to be like a step you can go, but there's usually not going to be multiples. Like here, you're like, I don't know, exponent over index, okay. Uh-oh. Exponent over index. Okay. Let the fun begin. This one, okay. I can't reduce it more in its current form As far as subtracting exponents, those are different. But remember that 1/4 is a radical. I can't have a radical in the denominator. So I got to fix this. So here's the goal. I'm just going to put this over here. My goal is for down in the denominator, that just ends up being y, or y to the first. So what would you have to add to 1/4 to get to 1? 3/4. So we've got to multiply the numerator and denominator by 3/4, because remember, you're adding exponents when you do this. And for this to be rationalized, that has to be a whole number. So what that's going to now turn into is we're going to have y in the denominator, or y to the first. You can leave this as x to the 3/4, y to the 3/4, or you could do xy to the 3/4. They're the same thing. Perfectly fine. But never, 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 ever can we have any sort of a root or a fraction in the denominator of your final answer. If you do, we gotta fix it. So that one, we might have to give that one a star. That one was a little kooky. And so as we do these, and actually I'm going to go to number 8 because these are similar, but 8's a little weird. You're like, all right, they're both y, that's cool. We're subtracting, okay. So let's see here. I need a common denominator. So looks like 8. So 4 times what gets me to 8? 2, right? Uh-oh, I see what's coming. So I look, and I'm like, all right, subtract them. 2/8 minus 3/8 is negative 1/8, but I can't have a negative exponent in my answer. So I got to flip it. 1 over y to the 1/8. Oh, crap. Here we go again. Same issue we had over here. That can't be y to the 1/8. It needs to be plain old y, or y to the first. So I'll ask again. 1/8 plus what is going to get me to 1 whole? 7/8. And you're going to be tempted. I know I would be if I was first looking at this stuff. You're going to want to go now and you're going to want to subtract the exponents again because, hey, they're both y, but you're going to end up right back where you started if you do. Once you get this to where that's a whole number in the denominator, it's time to cut it off. It's time to stop. So there will be a couple of those that show up in the homework practice to kind of get you a little bit of a heads up, but be aware of those just in case. They're little stinkers. And then the rest of these are just going back to what we've been doing. Just making sure, again, if your roots are the same, index, Hardy, index. If your indices are the same, you can go ahead and do the operation underneath. So here, I can multiply the 4 and the 16 together. And that helps me because 64 is a perfect cube. So knowing the property allows me to simplify it when I wouldn't be able to any other way. Same thing here. They're both 4th roots. Go ahead and divide your coefficients. Open it up here. 81's a perfect 4th. So you can see where we're heading with that, okay? When they're the same index root, or if I put fractional exponents on them instead. If this had been 162 to the 1/4 and 2 to the 1/4, it's the exact same thing. We're just getting used to the different ways that these numbers can get thrown at us. So nothing real complex as far as that goes. And I think, if I'm remembering right, yep, I got one more little bit of crazy at the end. But it's not really, because we've seen this. Right in the simplest form. Hey, we've seen this stuff before. Fifth root, ooh. 32 is a perfect fifth. It's 2. 5 goes into 5 one time, nothing left over. 5 goes into 10 2 times, nothing left over. Like, okay, that wasn't bad. Hardy, there's got to be a bad one in here. No, there doesn't. Fourths, we got 16. That takes me to 2. 4 goes into 4 twice, once. Oofda. 4 goes into 9 2 times, but we have 1 left over. 4 goes into 20 5 times. We're set. If it's in parentheses, leave it in parentheses. 4 goes into 32 8 times. That's done. Yeah, do not try to multiply that out. You'll be there for a long time doing that. But these last two I do want to chat because they're a little odd. These, your world is going to be much easier if we look at these as exponents. So here's what I'm going to have you do. I'm just going to, just a second here. So I've got 3 to the 1/2, because that's what the square root is. But now I want to take the square root of that. So I want to take that to the 1/2 power. And so since we're going power to power, we're going to multiply the exponents and get to my answer. And so the same thing is going to happen over here. And you might see there might be a shortcut if you look at this next one. So I've got 7 to the 1/5. And then that radical outside of it would be the 1/3 power, because it's a cubed root. Multiply the exponents together. So again, putting it into the fractions never going to be a bad idea, but if you're quick about it and go, well, wait a minute, that's a 2 and that's a 2. So 2 times 2 is 4. Oh, that's the denominator. 5 times 3 is 15. Oh, that's the denominator. So whenever you see roots, if you have doubles, you can actually just multiply the indices, the indices together to get your denominator. Otherwise, just make it a fraction. It won't be too bad that way either. So that's going to bring us to the end of new stuff before your next quiz. Now, I will mention one thing, because some of you, if you've been working along in the practice, you're like, okay, so here's the practice. I'm going to do me some odds again. I'm going to check some answers. I'm cool. And then you notice, you're like, wait a minute. Thought you said this is the last section. 119 is in here. You're never going to guess. I screwed up and I got one extra sheet in there. So before we turn in practice on Monday, we're going to get the 119 out of there, because that isn't going to come until after our quiz on this one. 119 is not in the quiz. So the preview will be the last thing in here you need to work on. This does cover everything that we've chatted about here since the last summative that we had. So be checking those. Again, the answer key for this and the preview video are up already, but I will be happy to take questions tomorrow.